Hello everyone, it's me again, Miss Jennifer, your biology, chemistry, and your science teacher. I would like to welcome you all to our second online class. So before we proceed with our discussion today, let's have a short review first in our last topic.
If I ask you what is the similarity between a sugar grain and a diamond, maybe you'll say that they both are lustrous. And what if I ask you the similarity between a diamond and a graphite? A graphite is just this piece of black stone used in laboratories. Maybe you'll think there is no similarity. Is there really no similarity between these two? The answer would surprise you. There is something common between all these three things. I'm referring to the element that these three are made up of. I'm referring to carbon. Wait a second. Are we saying that the sugar, the radiant diamond, and graphite are all made up of carbon? Absolutely. In fact, diamond and graphite are almost pure forms of carbon. They are majorly made up of carbon with a few minuscule elements that come as impurities. But how can there be so much difference in the looks of different materials made up of the same element? How can it be possible that the substances made up of the same element, carbon, appear totally different? And wait, they also have different chemical properties. The looks are different, the chemical properties are different, but they're made up of the same element, carbon. Is this some kind of magic? Well, the magic lies in the element itself. The element carbon has several interesting properties, and that's what makes it special. It is capable of forming bonds with most of the elements. That is the reason why carbon compounds are quite commonly found everywhere. But did you know that carbon is actually present in very small quantities in the Earth's crust and also in the atmosphere? That's the irony. In spite of being present in almost every compound around us, carbon accounts for almost less than 1% in the Earth's crust and in the atmosphere. But have you ever wondered what makes carbon so unique? What gives carbon the capability to have so many different properties? Let me give you a hint. Can you tell me what are the chemical properties of elements based on? Yes, they are mainly based on the atomic number. The atomic number is the number of protons in the atom. And why is it so? Because the number of protons in an atom is equal to the number of electrons in it. Right? And electrons, valence electrons to be precise, are the ones that participate in chemical reactions. So is number of electrons in the outermost orbital our answer? Absolutely. The chemical properties of an element are based on the number of electrons present in its outermost orbit. We know that the atomic number of carbon is 6. That means the electronic configuration of carbon is 2, 4. Now let me ask you a question. Look at the atomic structure of the carbon atom. To achieve stability, will carbon take 4 electrons or will it donate 4 electrons? Well, the simplest way to achieve the octet state will be by sharing electrons. This gives us the answer to many queries. Yes, the fact that carbon can share its outermost electrons with any other element gives it the capacity to form chemical bonds with various other elements. Now let's meet in the next video wherein we will learn about the covalent type of bond. Then we will move ahead to learn more about the bond formation seen with carbon.
For today, let us discuss about the hydrocarbons. So, what is a hydrocarbon? Do you have any idea? Hydrocarbons. Hydrocarbons are the simplest of all organic compounds containing only carbon and hydrogen. Again, hydrocarbons are containing carbon and hydrogen. Hydrocarbons are classified into two groups. So there are two groups of hydrocarbons. What are these two groups? We have saturated, and the other one is unsaturated hydrocarbon. So what do you mean by saturated hydrocarbon? Saturated hydrocarbons, the molecules are made entirely of carbon-carbon single bonds. Okay, so there's only a single bond between the carbons. For example, this one. So this structure is propane. Then it has a single bond in every carbon. So this is what we call a saturated. Again, there's only single bond of a carbon. Okay, saturated hydrocarbon are also called alkane. Okay, another name for saturated hydrocarbons are alkanes. Example of this, so this is the structural formula of butane. Alkanes are family of simple hydrocarbons with the general formula of CnH2 plus 2, where N is equals to 1, 2, 3, and so on. Alkanes are saturated carbons, and each carbon atom is bonded 4 other atoms, carbon or hydrogen atoms, by single covalent bond. Again, single only. So again, what is the general formula of an alkane? Can you still remember? So this is the general formula of an alkanes. We have CnH2n plus 2, where N here, this N refers to the number of carbon atoms in one molecule of alkane. So let us use the formula of alkane in the given example. So I have here an example of methane. So methane, this is the structural formula where there's only one carbon combined with 4 hydrogens. Okay, so this is the formula of methane, CH4. So how do we come up with this formula? Okay, so by the use of the formula of the alkane, let us find out. So we have here CnH2n plus 2. So in this formula, how many carbons are there in methane? Only 1. So that's why we will write C, and then instead of writing letter N, let us replace it with number 1 because there's only one carbon atom. Next, let us copy H2 here. So H2 times 1, because in the formula we have H2n where n refers to the number of carbons. So in the given example, carbon here, there's only one carbon. So that's why H2 times n, and then copy plus 2 in the formula, plus 2. So the result, C1, so there's no need to write 1 here because it's only 1. So just write letter C. Then H4. Why? Because H2 times 1 is equals 2. Plus 2 is equals 4. So that's why we have CH4. Got it? So the structural formula of methane, one carbon atom bonded with 4 hydrogens, and this is the formula CH4, where only one carbon and 4 hydrogen atoms. Okay, another example using the formula of alkanes. We have methane, we already finished that one. Then ethane, we have 2 carbons, but it's a single bond because alkane is a single bond of carbons. Okay, so how many carbons are there in ethane? So there are 2 carbons. That's why our C here, C2, so replace N, Cn into C2. Next, copy H2 from the given formula, H2N, where N is 2 from the number of carbons. H2 times 2 plus 2 equals, so we need to write 2 here because there are 2 number of carbons. So C2, then H6, because 2 times 2 is equals 4 plus 2 is equals 6. So this is the formula of ethane, and this is the structural formula of an ethane. What about propane? So it's just the same procedure how to get the formula of propane, which is C3 and H8. So there are 3 carbon atoms here. So we need to write C3 and then 8 hydrogen. So how do we know? We need to do the formula H2 times 3, 3 from the number of carbons, plus 2. So 2 times 3 is equals 6 plus 2 is equals 8. So we have C3H8 for the propane. Did you get it? It's so easy. So I require you to practice at home in the given formula. Okay, so the name of the straight chain alkane consists of 2 components. So we have the root and the ending. Root denotes the longest carbon change, and the ending denotes the family of organic compound. So usually alkanes ends with ANE. So for example, naming of alkanes. So we have this one. The root part indicates how many carbon atoms there are in longest continuous carbon. And the ending part indicates the family of compound. So we're just talking about alkane. The family of compound here is the alkane only. Okay, so number of carbon atoms, 1 until 10. Then the root name for 1 is meth, 2 is eth, 3 prop, 4 but, 5 pen, and so on. So these are the root name of the carbon atoms. Next is we have this one. So this time we need to add ANE, or the end part of the naming of alkane. So ANE indicates the compound is the member of the alkane family. For example, this one. So number of carbon atoms 1, root name of 1 is meth, name of alkane is methane. We just add ANE in the end part. The same with carbon atoms number 2. The root name of 2 carbon atom is eth plus ANE, because AN is it's a family of alkane. So we have ethane, 3 propane, 4 butane, 5 is pentane. Number 6, hexane, 7 heptane, 8 octane, 9 nonane, and 10 is decane. Okay, you name it. So I have this given example. I have 3 carbon atoms here, bonded in a single atom, and I have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So what do you think is the name of this alkane? Is it methane, ethane, propane, butane, and pentane? Take note, there are 3 carbon atoms that are bonded together, a single bond. So what do you think is the answer? Okay, if your answer is propane, then you are correct, because there are only 3 carbon atoms and 8 hydrogen. For the quiz, I attach a file in your Google Classroom for you to answer the questions. So after you answer the questions, kindly submit it because that will be your attendance.